Okay, this is a video on adding vectors. So if we have two vectors, like vector A and vector B, if we want to add those two vectors together, just switch back to this color, we can place them head to tail and then draw a resultant vector, which is how we add them. So let's just draw, if we have, there's vector A, and then I'm going to take the tail of vector B and attach it to the head of vector A, like this. And then the vector that will turn this into a triangle is called the resultant vector. Ugh, I can't draw a straight line. And that is what the vector A plus B will be equal to, also called the resultant vector. So if we want to add up two vectors, that's how we do it. Let's say we want to subtract vectors, because maybe we want to do that. So instead of subtracting vectors, we actually add the opposite vector. So we would take vector A, and to subtract vector B, we would actually take the vector, the opposite vector to B, and we would just add those vectors. So there's vector A, and then vector B, negative B is going that way. Sorry, I'm just gonna move that over there. So then our resultant vector would be this one, and this would be the vector A minus B. So that's how we add and subtract vectors. We just place them head to tail and then draw this thing to make a triangle. Okay, so we decided to start with crazy word problems for adding two vectors together, because that seemed smart at the time. So let's just do a straightforward question where, let's just say somebody is walking like 20 meters east. So there's a person and they're walking 20 meters east, and then they turn and they walk 10 meters south. They walk 10 meters south. And we want to figure out their displacement. So we want to figure out how far are they from their starting position. So we're going to add these vectors together to figure it out. So how we do that is we use trigonometry, because basically we're finding the magnitude of that vector. So let's call this vector D for displacement. And we're just going to find the length of that side. And since it's a right angle triangle, we can actually just use the Pythagorean theorem. So to find the magnitude of vector D, I'm going to just do 20 squared plus 10 squared. And then, whoops. Sorry, and then I don't know what that equals, but we'll just keep it as the square root of 500 meters. And then we also need a direction for this person. So, because a vector has to have a magnitude and a direction, so let's find theta. And to find theta, I tend to use, since we're doing a right angle triangle again, the sides that are given to me already, just in case I've made a mistake calculating displacement. So I'm going to do inverse tan of 10 over 20, opposite over adjacent, which is, just grabbed a calculator, 27 degrees, I think. Hopefully I haven't messed that up. So that's 27 degrees. So then I can describe this person's walk as sorry, what's the square root of 500? Should I know that? Okay, sorry. So that's 22.3 meters. So I can describe this person's walk as 22.3 meters, and then maybe I want to say east 27 degrees south. And I know I said to always put south or north first, so if you want to change it, you can say 22.3 meters. And then maybe we just wanted to say, what's 90 minus 27? 63? South, 63 degrees east, if we figured out that angle. Okie doke. So that's a straightforward one for adding vectors. So that was displacement. Let's try a velocity one. Okay, so let's say you have an airplane, since that's what we were doing in class. And for this question, let's say we have an airplane with an airspeed of 500 kilometers per hour, and it's flying at a bearing of 40 degrees. And then there's a wind, a 150 kilometer per hour wind, blowing, I'm going to make this tricky, from 120 degrees. That's going to be confusing. And we want to determine the ground velocity of the plane. That just means the velocity of the plane in relation to the ground. So how fast is it going to go when you factor in the wind? So basically we're adding two velocity vectors together. Okay, so let's sketch this thing out. It's the trickiest part. So bear with me here, because we'll see what happens. Okay, so I got a velocity and a bearing of 40. So that's going to look something like this. One sec. Make it long. So that's 40 degrees, and it's going at 500 kilometers per hour. Then I got my wind. It's 150 kilometers per hour, and it's blowing from 120 degrees. So I'm going to just sketch that over here for you. So 120 degrees is going to be in this quadrant, and if it's coming from 120, that means it's going in this direction. So it's actually looking like this, right? So I actually think the easiest thing to do here is, I'm thinking I might just add a vector here, right? I think that will work. So now I know like this entire angle here will be 120 degrees. And that was 120. Oh, is it? Oh, no, 150. So this velocity is 150 kilometers per hour. Okay, so I got some figuring out to do. And then I've got my final resultant vector, which we'll call vector v, going like that. Okay, so my airplane was going at north 40. Then my wind was coming from 120 degrees, so I just drew it like that. You also could have added it up here if you wanted to. It's not a big deal. So let's figure out some angles that we will need. What do we know? Okay, we know this is 50, and this one right here is going to be 50, right? Because like 40 plus 50 will be 90. So we also could figure out this part, because 120 is the whole thing. So if we do 120 take away 90, that would be 30 degrees. So 40 plus 50 plus 30 is going to add up to 120. So the 120 degree angle was our like entire angle here. That was 120. But the angle that we care about now, sorry, this is getting crazy, but the angle we care about is just the angle that's in here. And that's going to be 50 plus 30. So the angle that we want is going to be 80 degrees. Whew, that's the trickiest part of these, I think, sometimes, just figuring out the angle. All right, so now we know the angle is 80, so I'm going to use cosine law to figure out the magnitude of vector v. So I'm going to do 500 squared plus 150 squared minus 2 times 500 times 150 times cos 80, and calculate that. Okay, we got 496, I think, kilometers per hour. So now we know the velocity of the plane. Well, we know the magnitude of the velocity of the plane, and now we need to find an angle. So like I said, like right from the starting position of the velocity vector, well, let's get that angle down there. And usually sine law works. So sine theta over 500 equals sine 80 over 496. And just isolate for theta. and you'll get an answer of 83 degrees. So now you have your magnitude and you have your angle. So you just have to write the velocity of the airplane. So velocity of the airplane is 496 kilometers per hour. Oh, and it would be good if we could say this 83 degrees in like a way that makes sense. That's going to be tricky. That's going to be the tricky part. Because what the heck? Okay, let's figure this out. How are we going to figure out how to say this? Okay, so we do know that what do we know? Can we say that, like, if we drew a thing here, do we know anything about that? Because this line is parallel to this line. Is that going to work for us? It's getting confusing. Do we know this angle? That angle would be 60, right? Because this one's 30. So this angle would have to be 60, and then, oh, low battery. What would this guy be? Oh, well, we know the whole thing's 83, right? So, like, all of theta is 83. So if we did 83 minus 60, we would get 23 degrees. Does that make sense? I think that totally worked. That was not as bad as I thought. Okay, so I just set up this line and this line are parallel. I just stuck a grid in between here. And then using my alternate angles, like I have this line coming through here. So then using alternate angles, I knew this was 60 because since this guy was 30, the other half would be 60 because, well, not half, but the other side would be 60 since it adds up to 90. And then using our alternate angles, we know that would be 60. And then since I know this entire angle is 83, I did 83 minus 60 to get 23. And that helps me because now I can say that it's north 23 degrees east, right? Because that's pointing north. And then just this part is 23. But yeah, that's tricky. Okay, so final answer is that. So that's an example of, we just did an example of displacement one at 90 degrees, so it's a little easier. And then we did one at a bunch of different angles. So that's a velocity example. And what else could we do? Or should I stop? I'll stop.